For tonight's homework, complete page 10 and then correct it with this option. This is a chance to review questions before SBAC, so try to challenge yourself to answer those questions to the best of your own ability. That way when you correct them, you can think about if you were on the right track. Enter the value of n, so the expression negative y plus 5 and 3/10 plus 7 and 2/10 y minus 9 is equivalent to 6 and 2/10 y plus n. So this is an example of a problem where we're given two equivalent expressions, so I can set them equal to each other here. And then I need to think about how can I rearrange this expression to make sense of it. Because you might originally look at this and think, how could I find two different variables? I have y and I have n. I need to find the value of n. Well, you can actually combine some like terms here and that'll help you make sense of it. So in this case, I can combine my y terms. Negative y, which is the same as negative 1y, plus 7 and 2/10 y would give me 6 and 2/10 y. It's just like I take away one y. And then I have 5 and 3/10 minus 9. So I know 5 and 3/10 minus 9 is going to give me a negative number. So if you remember, it's kind of like I subtract them, and then I use the absolute value of the number that has or I use the sign of the number that has a larger absolute value. So when I subtract these guys here, I get 3 and 7/10. And again, because I have positive 5 and 3/10 and I'm taking away 9, this is going to get me into the negative numbers. So this is going to be minus 3 and 7/10 or plus negative 3 and 7/10. And this equals 6 and 2/10 y plus n. So now you're hopefully noticing I have this term on both sides, which means n has to be equal to the other term. So this answer should have been negative 3 and 7/10. So take a moment and note if you had it correct. The next problem asks us to find the constant of proportionality from the table and then enter an equation in the form of y equals rx, with r being the constant of proportionality. So to find the constant of proportionality, you may remember to find r, or we often called it k, we took the y values and divided by the x values. So here, if I take the y value of 48 and I divide by 4, I get 12. If I take 60 and divide by 5, I get 12. If I take 96 and divide by 8, I get 12. So my constant of proportionality is 12. Now when I put it into an equation, I'm just going to write y equals 12x. And again, I can use my equation to check and make sure it's correct. So I could plug in, for example, 4 for x. That would mean that y equals 12 times 4. 12 times 4 would be 48, and I can see that indeed I get 48. So take a moment and note if you had that correct. You should have ended up with this equation right here. Dave buys a baseball for $15 plus an 8% tax. Mel buys a football for $20 plus an 8% tax. Enter the difference in dollars of the amounts Dave and Mel pay, including tax. Round your answer to the nearest cent. So let's take a look at how much each person is going to pay. So Dave is going to pay $15 plus an 8% tax. And so I've got a couple of options. I could find 8% of 15. So for example here, I could do 8 times 5 is 40, 8 times 1 is 8, plus 4 is 12, and putting in my decimal place, $1.20. So again, I have to pay attention though, Dave is going to pay $15 plus the $1.20 in tax. So he's going to pay $16.20 for his baseball. Mel is going to pay $20 plus an 8% tax. So I'm going to find 8% of $20. So 8 times 0 is 0. 8 times 2 gives me 16, so I get $1.60, and I'm going to go ahead and add 20 plus $1.60 for my tax getting added in. At that point I get $21.60, and now I'm going to find the difference of those two prices. So $21.60 minus $16.20 would give me $5.40. So you'll notice I don't actually have to do much rounding here. I know it says to round to the nearest cent, but it's pretty much already done for you. If you prefer to find the two numbers faster, you could multiply 20 times 1.08 to find the cost with the 8% included, or 15 times 1.08 to find the cost with the tax included, and that would give you these two numbers quickly, and then you could just subtract them like you saw here. Take a moment and note if you had that question correct. For number 4, we're going to determine if each statement is true for all cases, some cases, or not true for any case. So two vertical angles form a linear pair. When we talk about a linear pair, we're talking about two angles that are adjacent that create a supplementary relationship. And so unfortunately, when it comes to vertical angles are not adjacent, they're opposite from each other. This is a pair of vertical angles, for example, right here. And so this is not going to be true for any cases. Again, a linear pair needs to be angles that are adjacent and that are also supplementary. So they add up to 180 degrees. If two angles are supplementary and congruent, then they are right angles. It might help to make a sketch of this. So two angles are supplementary, and then they're also the exact same size. So if you think about 180 degrees for supplementary angles, if you cut that in half, then each of them would have to be 90 degrees. And so looking at this, they're both right angles. That's the only way that I could make this. So this would be true for all cases. The sum of two adjacent angles is 90 degrees. There's lots of different ways to make adjacent angles. For example, these two angles are next to each other. I could also look at other angle combinations. These two angles are next to each other. You might notice that adjacent angles could have all sorts of different sums. And so this is true for some cases. They could make 90 degrees. In the case of like a complementary angle pair, these two angles are adjacent and make 90 degrees, but they don't necessarily have to. The measure of an exterior angle of a triangle is greater than every interior angle of the triangle. So thinking back to what you know about triangles, if you think about interior angles of a triangle, in this case, this is kind of a small triangle, we could look at the angles on the outside. This is called an exterior angle. And here I would notice that this exterior angle is larger than my interior angles here. However, I could also make other types of triangles. For example, I could make something more like this, an obtuse triangle. And in that case, when I draw the exterior angle, it would actually be smaller. So this is one of those cases where it is true for some, but not necessarily all. Again, take a moment and notice how you did on that last question, and come ready to talk about any questions you have tomorrow in class.